Welcome back. This is a velocity time graph problem and it reads, a body starts from rest and travels distances of 540 meters, 1440 meters, and 900 meters in successive equal time intervals of 20 seconds. During each interval, the body is uniformly accelerated. Question 1. Calculate the velocity of the body at the end of each successive time interval. Question 2 reads, draw a velocity time graph for the motion. Question 3 reads, calculate the acceleration of the body during the second interval. What we understand from this problem is the body covers distance of 540 meters, 1440 meters, and 900 meters. Each of the distance traveled was covered in 20 seconds. And during each interval, the body was uniformly accelerated. So it means after covering the 540 meters in 20 seconds, it accelerated and then covers a distance of 1440 meters. Then it accelerates again and then covers 900 meters. So, which means 3 different intervals were covered. Solution, I can divide them into intervals. So let's say first interval, second interval, and third interval. So for the first interval, I can say the first distance that is given is 540 meters. Okay. The second interval, the body covers a distance of 1440 meters. And for the third interval, the body covers a distance of 900 meters. And each of the distances is covered in 20 seconds. And so the first time will be 20 seconds. The time for the second interval will also be 20 seconds. The time for the third interval will also be 20 seconds. But what else can we obtain from the question? Is the body starts from rest. So which means in the first interval, the initial velocity u1 will be 0 meters per second. We will need to know u2 and we will need to know u3, right? We'll find that. So the first question is asking us the velocity of the body at the end of each successive time interval, which means it is asking us the final velocity. So we need to know the final velocity v1, the final velocity v2, and the final velocity v3 for each of the intervals. Now, before going further, what I want you to understand is the final velocity of the previous event will serve as the initial velocity for the successive event. Always remember that for motion problems. So in that case, the final velocity for the first interval will be the initial velocity for the second interval. The final velocity for the second interval will be the initial velocity for the third interval. Okay? So the first question is asking us to find the final velocities, okay, at the end of each interval. So which of the formula or equation of motion can we use to calculate that? We can use S is equal to U plus V divided by 2 all multiplied by T. Now, since I want to find V, what I can do is I can expand this to have S is equal to U times T is UT plus V times T is VT divided by 2. Now, if I cross multiply, I will have 2 times S is equal to UT plus VT. That is 2S is equal to UT plus VT. Since I want to make V the subject of the formula, I can say 2s minus ut is equal to Vt. To find V, then I divide both sides by t, both sides by t. T cancels t. Then therefore, V is equal to 2s minus ut divided by t. We can use this to be able to find the final velocity of the body at the end of each interval, okay? So for the first interval, using V is equals to 2s minus ut over t. Because I am referring to the first interval, I will make everything 1. So that will be V1 is equal to 2s1 minus u1 t1 divided by t1. Okay? So V1 is equal to 2 times what was the distance covered in the first interval is 540 minus the initial velocity is 0 because the body started from rest, multiplied by the time is 20 seconds all over 20. So V1 is equals to 2 times 540, that gives 1080 minus 0 times 20 is 0 divided by 20. So V1 is equal to 1080 divided by 20. Therefore, V1 is equal to 54 meters per second. So we have the final velocity at the end of the first interval as 54 meters per second. So which means this is now going to serve as the initial velocity for the second event. Okay, remember V1 will be equal to u2. The final velocity for the first event will be the initial velocity for the second event. All right, so therefore u2 is equal to 54 meters per second. All right. For the second interval, let's move on to find the final velocity. We can say using V is equal to 2s minus ut divided by t. Then since I'm referring to the second interval, it will be V2 is equal to 2s2 minus u2 t2 divided by t2. Okay, all signifying the second interval. So the final velocity of the second interval V2 is equal to 2 times the distance covered in the second interval was 1440 meters minus the initial velocity will now be 54 multiplied by time is 20 divided by 20. So V2 is equal to 2 times 1440 is 2880 minus 54 times 20 is 1080 divided by 20. So V2 is equal to 2880 minus 1080 gives 1800. Then we divide that by 20. Therefore, V2 is equal to 90 meters per second. So that is the final velocity of the body at the end of the second interval. Okay, so the final velocity for the second interval will be the initial velocity of the third interval. Therefore, u3 is equal to 90 meters per second. Okay, for the third interval, using V is equal to 2s minus ut all over t, then we can say V3 is equal to 2s3 minus u3 t3 all over t3. Substituting the values, V3 is equal to 2 times the distance covered in the third interval was 900 meters minus the initial velocity is 90 multiplied by the time is 20 divided by 20. So V3 is equal to 2 times 900. That gives 1800 minus 90 times 20 is also 1800 divided by 20. So V3 is equals to 0 divided by 20. And what is that? V3 is equal to 0 meters per second. So what does that mean? It means that the body comes to rest. If the final velocity is 0, which means the body comes to rest. So in summary, the body's final velocities are 54 meters per second at the end of the first interval, 90 meters per second at the end of the second interval, and finally 0 meters per second at the end of the third interval, which means at the third interval the body comes to rest again. So moving on to the second question, it asks us to draw a velocity time graph of this motion. So we're going to use these values that we have to draw a velocity time graph. Question 2, we're going to have velocity in meters per second on the y-axis and time in seconds on the x-axis. So you should bear in mind that each interval lasted for 20 seconds, right? So there was equal time interval. Okay, so we're going to have 20 seconds here, 40 seconds here, and 60 seconds here. For the first interval, the body starts from rest and it accelerated, right? So this is how it is. So that is the acceleration for the first interval, okay? And what was the final velocity? For the first interval, it was 54 meters per second. And the final velocity for the second event was 90 meters per second. Then for the third event, we had a final velocity of 0 meters per second, which means the body comes to rest. We should indicate that as a deceleration to rest. So this is going to be the velocity time graph. Always remember to indicate the origin 0. So we have something like this. Now, after the proper labeling, you need to write the headings. The velocity time graph. Okay. To summarize, a body starts from rest. It accelerates uniformly to attain a final velocity of 54 meters per second in 20 seconds. And the distance covered in the first interval was 540 meters. Then the body accelerated again to attain a final velocity of 90 meters per second at the end of the second interval. The time interval there was 20 seconds. Then finally, the body comes to rest. Okay, so it actually decelerated to rest because the final velocity was 0 meters per second. This is how the velocity time graph needs to be drawn for this motion. Moving on to question 3, it asks us to calculate the acceleration of the body during the second interval. That is, we need to find A2. So we know the initial velocity there for the second interval will be 54 meters per second. The final velocity at the end of the second interval is 90 meters per second. So V2 equals to 90 meters per second. And we know that the time in the second interval was just 20 seconds. If we use V is equal to U plus AT, then we're going to have V minus U is equal to AT. To make A the subject of the formula, we divide both sides by T, So A is equals to V minus U all over T. Okay, so let's specify. We are talking about the acceleration in the second interval. So it will be A2 is equals to V2 minus U2 divided by T2. So A2 is equal to, the final velocity is 90 minus the initial velocity was 54 divided by 20. So A2 is equal to 90 minus 54 gives 36 divided by 20. So A2 is equal to 1.8 meters per second squared. And that answers the question. Thank you very much for watching this video. If this is the first time visiting the channel, please do not forget to subscribe, like, and share the video.